Okay, students, so we're here with parallel line postulates and theorems, phase 2. Okay, so this is the second day we're practicing this. Why? It's a big punchline not only for this unit, but for the whole school year. In this picture, I can argue that this is a powerful picture because it kind of starts us off in being able to prove a lot of things about triangles. And I'm going to go on a rant about how great triangles are in a later unit. But this is just good stuff in terms of geometry overall. So, review. If two parallel lines, again, huge punchline, if two parallel lines, all right, that's two big words. And parallel lines are noted by these double arrows. The lines have to be parallel for all of the following stuff to be true. So, and then furthermore, transversal. We talk about transversal, but I know you youngsters like to forget what a transversal is. This is the transversal right here. All right, it's the line that just gets, or that intersects the parallel lines. So if two parallel lines are cut by a transversal, then corresponding angles are, you're not going to believe this, they are congruent. Wow. And then some examples. Now again, what are corresponding angles? They're in the same corresponding positions, such as angle 1 and angle 5. They're both like in the top left. All right. So angle 1 would be congruent to angle 5. And then I'm just going to rattle off all the pairs. 2 and 6, 3 and 7, and then 4 and 8. And again, this is a postulate, the corresponding angles postulate. We accept this as fact. We accept that 1 is congruent to 5. And then the rest of these are actually theorems, and we prove them to be true. So then, if parallel lines are cut by a transversal, then alternate interior angles are congruent. Wow. Insane. All right. Now, what does that mean? That means that angle 1 is congruent to angle 8. Angle 2 would be congruent to angle 7. That's it, actually. All right. Let me rearrange my notes too, just to emphasize things. All right, they're congruent. Let me actually put that over here. All right. Now, alternate exterior. Some people say, well, this really just means opposite sides of the transversal. So like 1 and 8 are on opposite sides of the transversal. Exterior means outside parallel lines. All right, that's just another way to think about it. Me personally, I think alternate exterior are kind of well-chosen words. They kind of describe it perfectly. For some students, it doesn't clearly make sense, so that's just another way to think about it. Opposite the transversal, outside the parallel lines. So then we have alternate interior angles. So even before we start writing stuff about that, we can say, well, these are going to be opposite sides of the transversal. They're going to be on opposite sides of the transversal, but interior means inside the parallel lines. Again, these words kind of self-describe the location. And then alternate interior angles, they again are congruent. And then the examples would be 3 is congruent to 6, 4 is congruent to 5. And then consecutive interior angles. This one, consecutive, this is the first and only time we see consecutive. Consecutive means same side of the transversal. And interior means inside the parallel lines. All right. So same side, inside, and consecutive interior angles are supplementary. These are the ones that are different. So in this particular case, measure of angle 3 plus the measure of angle 5 equals 180 degrees. Measure of angle 4 plus the measure of angle 6 equals 180 degrees. All right. So that's just a quick review. What the words mean, location, congruent, supplementary, all that fun stuff. Now we're also going to just look at some cases. So like this picture and this picture are actually very similar. All right. And in fact, this picture up top kind of leads us into this bottom picture. This is a little foreshadowing of what we're going to be doing in Unit 4. And what I really like about geometry is like basically everything we learned in the past is we're going to revisit later. All right. So these pictures look different, but they're actually very incredibly similar. All right. So again, let's analyze this picture. Notice we have parallel lines. All right. So what I like to do is just extend them. All right. Notability is great. There's a lot we can do in Notability that we can't do on a piece of paper, such as have access to all these highlighters, rotate, manipulate pictures, all this fun stuff. All right. Next, here, I'm going to erase this thing. Next, let's L and J. So let's just angle L, angle J. What's the relationship? Well, let's do this. This line connecting them, let's make it a transversal. All right, now let me see something. I'm gonna try something. I'm not too sure if this is gonna work. My Notability works. Let's see. Wow. Okay. So, what are the relationships with angle L and angle J? Now that one was L. This one up here is J. What is the relationship? By emphasizing the parallel lines and doing the transversal, we can see that L and J are alternate interior angles. All right. Again, let me copy, paste. I'll put that back to where it was. All right. So do you see how all I did was rotate this picture? And in fact, we're going to be working on rotations in next unit as well. So the relationship with L and J are alternate interior angles, and so they're congruent. Okay. And then what about H and K? Now this got a little messed up. Let me erase this. Let me just erase everything. You guys can keep it on your notes if you want. Anyways, again, I'm just going to extend the parallel lines. And then there's the transversal. Now H and K, well, you can even just turn your iPad. We don't necessarily have to copy, paste, and rotate. Or you might just realize that, again, this is just another pair of alternate interior angles, and they're congruent. Okay. And then down here, what do we got? L and H. All right, this is absolutely, you have to be able to do. There's no arguments. There's no saying, I think I can't do this. You have to be able to do this. L and H, you have to be able to say, well, here's L, there's N, and it goes to H. So you have to be able to identify angles using 3 letters. It's very necessary in this class. Then we got K and H. So K and J. So what's the relationship with these 2 angles? Again, have to be perfect at this. They're 2 angles, they're forming an X, they share a vertex. These angles are vertical angles. Okay, they never go away in this class. They're here to stay forever. What's so great about vertical angles? They're congruent. Okay. And then, how do we know angle BAC and angle DCA are congruent? Let's just focus on that part first. BAC and DCA. So again, what angle is angle BAC? That's going to be this angle right here. And then we got DAC. or excuse me, DCA, which is going to be this angle here. So it's saying, how do we know that these angles are congruent? Well, again, we can even just emphasize it further. We got the parallel lines. We got the transversal. Just emphasizing things on our pictures. How do we know that they're congruent? We're going to write angle BAC is congruent to angle DCA by the alternate interior angles congruence theorem. I made a weird E. Deal with it. Capital E out of nowhere. All right, they're congruent by the alternate interior angles congruence theorem. And we're going to make a side note. AB, line AB was parallel to DC. And again, remember, parallel lines is a big punch line for all these theorems. And that pun was purpose. I did that on purpose. The parallel lines are a big punch line. Get it? I made a joke. All right. So it's saying, how do we know that those two angles are congruent? But how come? Let me pick some different colors. Let's use this weird purple. DAC. So DAC would be this angle right here. So DAC and ACB. Okay. Well, we can rotate our iPad. We can kind of look at it sideways and say, well, we got these two lines. We got a transversal. So shouldn't these two angles be alternate interior angles as well? Okay. We don't know because although, I spelled although wrong. Oops, there we go. Although alternate interior angles, we don't know if line AD is parallel to line BC. It never tells us those lines are parallel, so we can't use the theorem. That's it. That's the punchline. Okay? Cruising right along. How many more of these do we got? This will be the last problem for this video. What is the defined relationship with angle A? So first, let's press pause right here. Reminder, there's only one angle coming off this vertex right here. So this is clearly angle A. And then CBE, we have to use 3 letters because there's all kinds of things going on. All right, what is the defined relationship? You might be able to tell immediately. There might need to be some emphasizing going on, but if I extend these parallel lines and then do this, extend that line, I can see that they're, OMG, they are corresponding angles. And they are congruent. It said, are they always congruent? Are they always supplementary? They're always congruent. There's actually a case where they can be supplementary, and that's when we got some perpendicular lines, but that's for another unit, or another lesson, I should say. Okay, that's it for this video. Stay tuned for more.